Welcome to Solving Quadratic Functions by Quadratic Formula and all methods. The best way to use this video is to take notes while I'm teaching, pausing whenever necessary. And every time the video arrives at a you try, pause and attempt the problem. The solutions will be shown when you press play along with the work. We'll cover the following topics in this section. So what does it mean to solve a quadratic function? Well, it means we're looking for the x-intercepts. We don't usually call them x-intercepts. A lot of times we call them roots, zeros, or solutions. There are three methods for solving quadratics: graphing, factoring, and quadratic formula. When you solve it algebraically, three things can happen. You could end up with 2 zeros, 1 zero, or no real zeros. What that looks like on a graph is 2 zeros, 2 places it hits the x-axis, 1 zero, 1 place it hits the x-axis, and no zeros where it's not hitting the x-axis at all. So with the quadratic formula, this is the method that works for all quadratic functions. So if we were asked to solve this, I always try and factor it. So when I try to factor it, I realize, oh wait, I can't divide all my coefficients by 3. So I say, all right, I guess we'll try graphing it. But when I try graphing it, I get these numbers that don't exactly work out. I need another method, and that's where the quadratic formula comes into play. It works for every single quadratic function. So the way the quadratic formula works is it's the opposite of b plus or minus the square root of, so it's a big square root symbol, b squared minus 4ac all over big fraction bar 2a. So these are all the methods of solving quadratics plus my opinion. You can solve quadratics by graphing. We rarely do that because it just takes so long. Factoring if we can, because usually that's the quickest, and quadratic formula if we can't factor. So this first example solved the quadratic function. So we can't factor it, divide by 2, and I don't want to graph it, so we're going to use the quadratic formula and label each one a, b, c. X equals the opposite of b plus or minus the square root of b squared, use a parenthesis, minus 4ac, extend if you need to, all over 2 times a. Now take a moment and double check that your radical's big enough and that your fraction bar is big enough. Now, the next thing we're going to do is type what I've highlighted only. Oops, forgot a parenthesis there. What I'm highlighting into the calculator. Do not type the radical. Do not type that. So we're going to get x equals 7 plus or minus and then radical all over 4. So go ahead and type that into your calculator. You should get 73. If you did not get 73, it's because you typed in the square root. If you got the value 8.54, it's because you typed that radical symbol in. If you got, let's see here. If you got negative 25, it's because you forgot to type in your parentheses. And the reason why we are done is we cannot simplify square root of 73. There are no perfect squares that go into it. This is two solutions. They're irrational, 7 plus radical 73 over 4, and 7 minus radical 73 over 4. All right, let's take a look at example 2. Solve the quadratic function. Let's see if we can factor it. We have a coefficient of a 1 here. Is there any number, what multiplies to 5? Does it add to 5? So we've got 1 times 5. No way to add it, so we have to use the quadratic formula. A, B, C. So x equals the opposite of b plus or minus big square root symbol, b squared minus 4ac all over 2a. Now again, type underneath the radical only. Don't actually type that radical symbol. So we get x equals negative 5 plus or minus the square root of all over 2. So what happens when you type that into your calculator? You get 5. We cannot simplify the square root of 5 at all, so we get negative 5 plus square root of 5 over 2, and negative 5 minus square root of 5 over 2. We're going to do a few more examples together. Solve the following quadratic function using the quadratic formula. Maybe we can factor. Oh, they say we have to use the quadratic formula. All right, so there we go. So 1a, b, c. X equals the opposite of b plus or minus the square root of b squared minus 4ac. Notice how I have to extend my square root all over giant fraction to a. Remember, type just underneath the radical, not the actual symbol itself. Negative 3 plus or minus the square root of. When you type that in your calculator, you get 49. Well, 49 is a perfect square. So this is equal to negative 3 plus or minus 7 over 2. And we'll split that up. We get negative 3 plus 7 over 2 and negative 3 minus 7 over 2. So that gives us 4 over 2 is 2 and negative 10 over 2 is negative 5. These are our zeros. Well, let's just do a quick check. Could we have factored this? What multiplies to negative 10 but adds to 3? Positive 5, negative 2, negative 5, positive 2. All right, we'll do a couple more together. Solve the following quadratic function. All right, it's 5. We can't put 5 into these, so we've got to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to type just underneath the radical here, not the actual radical itself, negative 3 plus or minus the square root of all over 10. And you get negative 11. This is not a real number, so the solution here is no real zeros. But sometimes you're going to want to simplify it even more. Maybe they want to know the imaginary number. If that's the case, we know how to simplify this. It would be negative 3 plus or minus I square root 11 over 10. If you're not sure how I got that I, go back to the simplifying radicals video and imaginary numbers. Let's take a look at what the graph would look like for no real zeros. Well, we know that a is positive, so it's going to look like this. The graph is probably going to look something like that. And when I graph it in Desmos, that's exactly what I see. All right, last one together. Solve the following quadratic. Well, I cannot factor because they don't all divide by 4. So we'll write a, b, c, and go ahead and use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. X equals, remember to type just underneath the radical into your calculator. A lot of times the mistakes that happen have nothing to do with the math and all to do with the calculator. So be really careful typing that in. We will get positive 289. And if you type that in your calculator, 289 is a perfect square. It is equal to 17. And so we can write this in two different ways. We get negative 7 plus 17 over 8 and negative 7 minus 17 over 8. We get 10 over 8, which is 5 over 4. We get negative 24 over 8, which is negative 3. These are our solutions. So go ahead and give these problems here a try, and then press play when you're ready to see the answers. Now, let's take a look at solving quadratics using all methods. At this point, you know how to graph, you know how to factor, and you know how to use the quadratic formula. So now I'm going to give you these 4 problems. I'm going to say you can solve them using any method you'd like and explain why you chose each method. When you press play again, you will have all my work plus my reasoning. Maybe you decided to use quadratic formula for all of them. That's perfectly fine as well. And that concludes solving quadratic functions by quadratic formula and all methods.